Again, welcome to Introduction to Data Mining, ITS 632. And in this lectures, we're going to cover different types of data. Again, this lecture is in our textbook, section 1. So our main objective, again, is to go through what is a data and also talk about different types of data that we can mine or can be used in data mining. So first, we start with what is a data? Here we say data is a collection of objects and their attributes. We can also use the term their characteristics. So example of a data can be students' data. And then a student will be the data object. And the student last name, first name, address, grade, etc. will be their attributes or the characteristics. So again, a data is a collection of data objects and their attributes. So a data set can often be viewed as a collection of, again, data objects. And we use other names for a data object as a record, point, vector, pattern, event. And event is used mostly in statistics, case, sample, observation, also used in statistics, and also entity. Entity is used in database. So an attribute is a property, or as we said, a characteristics of an object. So example is we have a student. A student will be the data object, and then the attributes or the characteristics of a student, again, can be the last name, etc. Here we have example of a attribute can be the eye color of a person or a patient's temperature. Attribute also can be called as a variable or a field, characteristics or features. Also, a collection of attributes will normally describe an object for us. So if I have an attribute of a last name, first name, the grade, and this can describe the student objects. Also, object is known as record, as we said earlier, the point, case, sample, entity, or instance. Again, depends on the type of subject you are taking. For example, in database, we may call it record. In statistics, we may call it sample or observation. Also database, we may call it entity. So it depends. So what is an attribute values? Here we say attribute values are the numbers or symbols. Also, it can be a text that are assigned to an attribute. So a student last name will be the attribute value, which in this case, it will be a text, such as James, Emmanuel, or student's age, 27. This time it will be a value. So attribute values can be a text, it can be a symbol, or it can be values that we normally assign to an attribute. Also, the distinction between attributes and attribute values. And so the attribute will be the name, the characteristics name. So example of an attribute will be last name. Then attribute value will be James. So James is actually the data object. So here we say same attribute can be mapped to different attribute values. So example can be a height can be measured in feet, or a height can be measured in meters. Also, different attributes can be mapped to the same set of values. So we have an attribute value for ID and age. They are all integers, they are all numbers, but their properties may be different. So for example, we know student's ID, we cannot find the average value or the sum of student ID. Even student ID will be a categorical data. We can't do arithmetic operations on it. But with student age, it's a numerical value, a quantitative. We can find the mean, median, addition, subtraction, any arithmetic operation on it. So the properties of an attribute values can be different, as we said. So ID has no limit, but age may have a limit. We know a person can never be 1,000 years old or 500 years. There's a limit. But ID, we can choose any number. There's no limit. So next we talk about different types of attributes. And this is also covered in statistics. There are at least 4 different types of attributes. We have the nominal, ordinal, interval, and also we have the ratio. So nominals can be values that we cannot do an arithmetic operations on. We can never do an arithmetic operation. So example would be ID numbers or my eye color or my zip code. I cannot add or find the mean of a zip code. So nominal data, the only arithmetic operation we can perform on nominal data will be the mode or counting. Then we have the ordinal. Ordinal means again something that is in order. So ordinal will be example rankings. Example, the NBA league, New York Knicks is first, Brooklyn Nets second. So we put them in ranking or grading system. Student A got grade A, student B got grade C, etc. So ordinal values are normally values that we can put in order. So that means in this ordinal operation, arithmetic operation that we can perform in ordinal can be everything that we can perform in nominal, which in this case is counting or mode, but including less than and greater than, or less than equal, greater than equal. So with ordinal, we can perform a relational operation greater than or less than and equal. The next one is interval. And the different interval can do almost all the arithmetic operations, but with interval, the value 0 means something. Again, the value 0 means something. So a very good example would be the temperature. The weather temperature, if it's 0, that means it's very, very cold. But in ratio, which is the last one, if it's 0, it means there's nothing. So a very good example would be, again, my bank account. In my bank account, if the balance is 0, it means I don't have anything in the bank. So 0 means something. So with interval, we can do all the operations for nominal and ordinal, also including addition and subtraction. Then with ratio, we can do all the arithmetic operation for nominal, ordinal, and interval, including multiplication and division. So this means in ratios, we can do counting, or we can find greater than or less than or equal. We can also use the addition and subtraction, and we can also use the multiplication and division. So those are the 4 different types of attributes that we are going to encounter in our data analysis or data mining course. So these are the operations as we are saying earlier. So the type of an attribute depends on which of the following properties it possesses. So with the nominal, it's only distinctness, equal or not equal, that's it. With the ordinal, including greater than or less than. Then with the interval, we including plus or minus. The multiplication section will be our ratio. So with ratio, we can do distinctness. We can do ratio, we can do distinctness, order, addition, and multiplication. So that's what we said here. Nominal attributes only distinctness. Ordinal attribute is distinctness and order. Interval attribute is distinctness, order, and addition. Then ratio, all the 4 properties. So we have some table here with some example. The attribute types is on the left side. We have nominal, ordinal, interval, and ratio. Then we have the description of each. Then we have an example. Then what kind of operations we can perform there. So when we look at the nominal, we can see that with the nominal, we say the values of a nominal attribute are just different names. And nominal attributes provide only enough information to distinguish one object from another. So whether it's equal or not equal. So a very good example would be the eye color, female or male, employee ID or zip code. You can see that all these attributes, we cannot do much arithmetic operations on, like addition, subtraction, multiplication, division, but we can count, or we can say whether it's equal or not equal. So example of operation we can do here is the mode, counting. We can also find the entropy, then also the contingency. We can also find the correlation. Then we can also do the chi-square test. We know a chi-square test uses qualitative or categorical data. And the nominal data is a qualitative data. So as we mentioned earlier, there are two types of categories of data. Either we have the categorical or qualitative, which is the nominal. But quantitative or numerical values, in this case, it can be both interval and ratio, and possible ordinal also. So with the ordinal, the values of an ordinal attribute provide enough information to order the objects, so whether greater than or less than, to put them in order. Example would be the hardness of minerals can be good, better, best. These are in order. Or grades can be A, B, C, and D. Or street numbers can go in order, 100, 120, 150 street numbers. So anything that we can put in order, we take the ordinal type of values. Then the next one is the interval. So with interval, we can perform, again, we can almost perform everything, including everything of nominal, ordinal, then including addition and also subtraction, addition and subtraction. And the only thing we know in difference between interval and ratio is that with interval, 0 means something. So calendar date, temperatures, whether in Celsius or Fahrenheit. With interval, since we can do addition and subtraction, means we can find the mean, standard deviation, or we can do a PSC correlation, T test, and also F test. That's hypothesis testing. Then the last one will do almost every operation, every arithmetic operation. So whatever nominal, ordinal, interval can do, ratio also can do. Then including multiplication and division. So example with ratio also can be temperature, Kelvin, or monetary quantities like my checking balance account or the price of a goods. We can also do counts, age, weight, length, etc. So with that also we can do geometric mean, harmonic mean, percent variation. We can also do hypothesis testing on ratio values. So these are the attribute level. Again, nominal, ordinal, interval, ratio. Here we want to talk about transformation. So with nominal, we can do any permutation of values. Now, if all employee ID numbers were reassigned, will it make any difference? That would be a comment. With ordinal, again, everything will be an order. So an order preserving change of values. Medium, large, extra large. With interval, our main concern is the 0 means something. So temperature again is a good example. Then with ratio can be anything. Length can be measured in any measurement, either in feet or in meters. So these are the main two types of, we saw that those four are the levels of measurement: nominal, ordinal, and we also have the interval and then the ratio. These are the level of measurement, but actually the attribute values are or attribute types are break into two: the discrete attribute, and also we have the continuous attribute. So with the discrete attribute, it has a finite or countable infinity set of values. So it has only finite or countable infinite set of values. So example of a discrete attribute can be the zip code, count, or set of words in a collection of documents. So which means nominal is a discrete attribute. And we say here it's often represented as integer and variables. Also, binary attributes are a special case of discrete attributes. Then we have the continuous attribute. Continuous attribute will have a real numbers as attribute values. So example can be temperature, height, and weight. So this means the interval and ratio can be a continuous attribute. And we say practically real values can only be measured and represented using finite number of digits. So continuous attributes are typically, again, represent as a floating point values. So these are the type of sets, data set we have. So for example, we have record, graph, and ordered, and the list keep going. But before we talk about types of data set, we should also know that the general characteristics of data set will be the dimensionality. The dimensionality of a data set is the number of attributes that the objects in the data set possess. So if the object possesses two attributes, then we have two dimensions, three attributes, and this is called a dimensionality. And also in data preparation lectures, we're going to discuss about dimensionality case, which means if I have a data with so much attributes, it will take long for the algorithm to process everything, which takes longer time. And sometimes the algorithm can even confuse with so many attributes. So we have some method that we can do to reduce the dimension of the attributes. Reducing dimension of attribute means, again, we want to reduce the number of attributes the data objects has. So we can say that data with a small number of dimensions tend to be qualitatively different than the moderate or high dimensionality data. Also, the difficulties associated with analyzing high dimensionality data are sometimes referred to as the case of dimensionality. So again, we have a techniques in data pre-processing that make it possible to reduce, again, the number of attributes. Also, one of the characteristics of data set will be sparsity. And another one is the resolution. So for some data sets, such as those with asymmetric figures, most attributes of an object have values of 0, and in many cases, and fewer than 1% of the entire entries are non-zero. So in a practical sense, we say a sparsity is an advantage because usually only the non-zero values need to be stored and manipulated. This results in significant savings with respect to computation time and also the storage. That's the computational compressivity concept. And also resolution is one of the characteristics of data sets. So it's frequently possible to obtain data at different level of resolution, and often the properties of the data are different at different resolutions. So those are, again, the three major characteristics of data set: the dimensionality of the data set, sparsity, and also the resolution. So we have different types of data. Again, we have a record. In record, we can have a data matrix, more or less like a tables, which consists of rows and column, or a regular document, document data or transaction data. So much data mining work assuming that the data set is a collection of records or data objects, and also each of which consists of a fixed set of data fields, the attributes. And so, for example, of a database, relational database, we can store values in more or less like a table. The rows is the whole set of data objects, which is the record. And each field is called the attributes, like last name, first name, etc. So we may have a records can be, as we said earlier, it can be a data matrix or document data, or also transactional data. So a transaction data is a special type of record data where each record or the transaction involve a set of items. So example would be a grocery store. I bought few items, let's say peanut butter, bread, and milk. Again, this is a transaction data set. And normally this type of data set, we call it the market basket data. When we cover the association algorithm, we're going to discuss about the market basket data. In our previous lectures, we said the association is a data mining algorithm that make it possible to find two or more variables if they are related, associated, they varies. So our case with the market basket data, I want to know what percentage of customers that buy bread, they also buy milk, or buy bread, they also buy meat or something. So we also have a graph data, which is like the World Wide Web, good example, and also the molecular structure, chemical data set. So a graph can sometimes be a convenient and the most powerful representation for data, especially when we are representing data in hierarchy form. So we will consider the two specific cases. Again, the graph will capture relationship among data objects, and also the data object themselves can represent as a graph. And normally, the relationship among the objects frequently will convey important information in graph. In such cases, we can say that the data is often represented as a graph, and the data objects are mapped to nodes of a graph, while the relationship among the objects are captured by links, or sometimes we use the term the edge. A graph normally will consist of a node and a line or a link between two nodes or more, which we also call an edge. Also, we have an ordered data. So ordered data can be sequential data concept. So here we have a spatial data, temporal data, sequential data, and genetic sequential data. So a spatial data normally is a data that you represent in space, location, like a GPS data set to be a very good example. And also a sequential data also can be called temporal data. That can be thought of as extension of record data. And the temporal data means the data is dealing with time. Time is more or less like a time series data. For example, the stock market data set is time series because the stock price changes with respect to time. Also, transaction data, retail transaction data can be a temporal data because things are bought we record the items that are bought with the time that they were bought. And also we have the sequential data will be a data that is in sequence. So a very good example would be, again, the molecular or DNA data set. Here we say genetic sequence data. We know that genetic sequence is AGTC. So we may have any other AGTTC, GTCA. So that's in sequential order. So sequence data consists of data set that has a sequence of individual entities, such as a sequence of words or letters. In the terms of genetic sequence data, it's in letters, the order of letters, AGTC. So that's a very good example of a gene. It's a sequential data. Also, time series data is a data that record values with respect to time. So most of the time, the x-axis will be the time. Spatial data, as we said, relate to the location. So here we say some objects have a spatial attribute such as position or area, as well as other types of attribute like location. So spatial data can be GPS data, as we said. So dimensionality, we talk about the cost of dimensionality. When a data set have a very high dimension, which is the attributes are so many, then we say there's a case of dimensionality. The reason why we say case of dimensionality is that if we have a data with a very high dimension, what happens is that the algorithm will take so long, or even sometimes the algorithm will confuse to go through all the algorithm and the attributes to make a decision. So dimensionality, we always want to have a normal, moderate attributes. And also we talk about sparsity, only presence count. Here we said sparsity deal with space, location. So for some data sets, such as those with asymmetric features, and we say some attribute of an object can have a values of 0, in many cases less than 1%, while the rest will be non-zero values. So sparsity is an advantage because usually only the non-zero values need to be stored and manipulated. Also, we talk about resolution. The patterns will depend on the scale of resolution. So this is an example of a record data that consists of collection record, each which consists of fixed set of attributes. So here we have a record with 10 data objects. So each will be a task ID. 1, 2, 3 up to 10, they are task IDs. So this is a record about taxpayers, and we have 10 taxpayers. We have attribute whether they get refund, yes or no. We also have their marital status, if they are married, single, or divorced, or widower. Then we have their taxable income, how much they make for the year. And then we have, this will be a training data set. So we have the crash label, which is to cheat whether yes or no. So our main goal of this data is to build a model that will be able to predict or to tell us whether a taxpayer cheats on tax, yes or no. So the first 4 attributes are the attributes of the taxpayer. The last also is the attribute of the taxpayer, but this is a very special attribute, which sometimes we call the target variable or the crash level. This is what we want to predict. We want to create a model that can be able to predict this result for us. Then we talk about the data matrix will be in the form of a table, rows and columns, as we can see example here. So here we say if a data object have the same fixed set of numeric attributes, then the data object can be thought of as a point in multi-dimensional space, where each dimension represents again a distinct attribute. Remember we talk about dimensionality on the case of dimensions always dimension represent attributes. Then a document data, here we say each document becomes a term vector. Vector means one record. So each term is a component or attribute of a vector. And the value of each component is the number of times the corresponding term occurs in the document. So here we have 3 documents, and we want to see how many times these words occur in each document. Transaction data, we say, as a very good example would be basket market data set. Here we can see it's grocery store in supermarket. The first customer buy bread, Coke, milk. Second customer beer and bread. Third customer buy beer, Coke, diaper and milk. Fourth customer buy beer, bread, diaper and milk. And the last customer buy Coke, diaper and milk. So we can use the association algorithm. Example would be the apron algorithm to find the relationship between all these transactions. What is the chance that if a customer buy bread, he will also buy Coke? Based on this data set, we can find what we call the support and the confidence to predict and find the association. We also have the graph data. Again, graph data, as we explained earlier time, a very good example would be the website data with the HTML code, etc. Then we also have chemical data. Example here is the benzene molecular C6H6. This also can be mined. Then other data. Other data is almost same as sequence data. So this is a sequence of transaction. We see that if a customer buy AB, also buy DC or BDC. So again, we can analyze this data set to find the relationship between the items or events that take place. Then we have the genomic sequence data. This is the AGTC form of genes or DNA. We can also analyze sequence data using data mining algorithm. We also have a space. We know spatial is the space, temporal is the time. So we might have a data that is both in space and time. So example would be this data is about temperature of different locations. So the temperature change with time, so that's why it's temporal. And also the data is from one specific space area or location. So this data set will be called spatial temporal data. So that will be the conclusion for our lecture on different types of data sets. So here we discuss about what is a data set. We know data set consists of attributes. So we discuss about what is an attribute, the characteristics of the data, and also we talk about different types of data sets. So again, wish everybody the best. Next lectures, we're going to discuss about how we prepare for data before mining and also data quality. So again, wish everybody the best. Thank you.